Welcome back, guys. In this next video in the series that we are discussing GRE subject mathematics practice book, I'm going to start from question number 16. And this is a very simple question and it is only related to set theory. It says that suppose x and y are sets such that f is a function from x to y, a and b are subsets of x. So for example, I have a function from x to y. And x is, let's say, a set like this. Sorry. So this is my x set and this is my y set. And there are subsets of this x, which are, let's say, a and b. C is a subset of b. So C is inside b. Which of the following statements must be true? So I'm given three statements. I have to analyze all these statements independently and see that which one of these is true and which one of these is false. Then I have options at the end. So I'll start from option 3, which is because it is going to be the simplest of all. It says that, okay, for example, I have a set B, then there would be something inside Y, which I call f of B. And I have a set C inside this, and obviously there would be a set C. There would be a set with the name f of C, and f of C must also be contained in f of B. This can be shown easily by using some sort of tricks to show containment of a set in another set. So it's really easy. It's like not a big deal to show. So for me, our like third statement is true. How you can show this? You can take one element from f of C. So x belongs to f of C. What does it mean that if I take one element from from, I'm going other way around. I'm taking one element x from C. Obviously, that element belongs to B because C is contained inside B. Now I operate a function on x. Then this f of x must be inside f of C, and this f of x must be inside f of B because this x belongs to C and this also belongs to B. So f of x is contained in f of C and f of x is also contained in f of B. It means if an element is in f of C, the same element is in f of B, we are done. So third statement is true. Seemingly, we can see that, okay, B can be true, B can be true, or D can be true, or E can be true. So we can just exclude option A and C. So this is the trick that sometimes works, that if you know a few things, then you can just exclude the options. Then you're left with less number of options. This is a good trick that I'll apply, that I usually apply when I'm going to appear in any exam. Now I will go for statement 1 or 2, depends how you find easy. I'm going for a statement 2. And the reason behind that is sometimes it is like very difficult to prove, but if you want to disprove something, you have to give one counter example. If you can give one counter example, you are done. You don't need to do anything else. So just give one counter example, that's it. So I'm just going to give one counter example for this and I'm done. So what am I doing? I'm taking a set with 3 elements and I'm going to name the set A. Sorry, not A, but B. Uh, What should I name it? I should name it A. Because I'm analyzing statement 2 and I have A and B. And I have another set and I'm going to name it B. It has also, let's say, 3 elements. So what is A? What is obviously, let me write here. What is A intersection B? A intersection B is null set. You can see there's nothing same in these two sets which I have drawn so far. So what is f of A intersection B is f of null set. So f of null set would be empty set again. So my left hand side for this thing is going to be empty set. Let us analyze right hand side. Let us take an example where there is a function which is constant function. You know very well a constant function is, let's say, f of x is equal to c. So every element is mapped to the same element. Every element is mapped to same element. And that element is, let's say, c or any element. So this one element is our f of a and the same element is our f of b. Because when you apply a function on a, you get something that is f of a. When you apply a function on b, you get something that is f of b. So f of a and f of b both have one element that is same. What is the intersection? Their intersection is that one element. So f of a intersection f of b is same one element that is c. So left hand side gives phi, right hand side gives c. So f of a intersection b is not same as f of a intersection f of b. This is one counterexample. Hence, this thing can't be true. So you have to exclude 2. So 3 is true, 2 is false. So I can now exclude option E. Now I'm left with 2 options, B and D. Now I have to look for statement 1, whether it is true or false. If it is true, I have to just select D. If it is false, then I have to select B. So for option 1, it's generally true. You can just verify by applying the tricks to prove that, how to prove 2 sets. So you have to prove 2 things. One thing is f of A union B is contained in f of A union f of B, and you have to prove f of A union B, not this, f of A union f of B is contained in f of A union B. It means one set is contained in other set is contained in the first one. Then your first statement is true, and you can verify this easily. And there are proofs available as well. So statement 1 is also true. So 1 is true, 3 is true. Hence the correct option is D. This seems to be like a lot, but when you work on these questions once, and in the exams, maybe the similar questions are being asked from you, so you can have a good grip on these all the questions. Okay, let us move ahead. This is again very simple question. It is related to real analysis, and if you know some definitions, if you know something, then you can do this easily. Yeah, but this question is not that much tricky and difficult, because it says that which of the following statements is false about the sequences in real numbers. So you have to look for false statements. I will directly hit B. Here's most common one. It says that every bounded sequence is convergent. It is not true, but every convergent sequence is bounded. So what do you mean by a bounded sequence? If I have a sequence, let's say -1 to the n, which gives me 2 numbers, -1, +1, -1, +1, and so on. You can see this is a bounded sequence. All the terms in the sequence can be bounded by a fixed number, but it is not convergent. Yeah. So it's a false statement. Obviously, this is very common statement. The rest of the statements must be true. Otherwise, you are in trouble. So let me tell you, starting from E going upwards, I have A and limit an is equal to some number A, which is going to be the limit of the sequence if and only if limit n tends to infinity n minus A is going to be 0. This is some sort of continuity of distance function in metric spaces. It's like you find the distance between A and A and you apply a limit. As we know that the distance function is continuous, so you can take limit inside, and limit A n is A. So it is distance between A, and distance between two same numbers is always 0. Or I mean A minus A, which is 0. So this is true. So these are general things which are true about real sequences. So I have a limit. It means if I have a limit of a sequence in R, it means I can say that the sequence is convergent in R. We know very well if a sequence is convergent, then this property is always true. When you take any two subsequent terms, their distance can be made as small as possible whenever you go far beyond some limits. This is called Cauchy sequence. So if a sequence is convergent, there is always Cauchy. It's true, we know that thing. And C is the limit is of a sequence is A, it means the sequence is convergent simply. And F is a continuous function, then this happens. F of an, and if you take limit n tends to infinity of f of an is same as f of ar. In other words, you can take this limit inside if function is continuous. So function is continuous, you can take limit inside and you're done. I say that this is the definition of continuity. We have other definition of continuity as well, what we have epsilon delta. But in terms of sequences, this is definition of continuity. That's it. So our correct option for this one is B. Let me remind you again. But statement A is either true or false. We have to just check. It says that every unbounded sequence is divergent. So we know very well that convergent sequences are bounded. So let me say convergent implies bounded. We know that thing. So I'm taking just contrapositive of this statement. Contrapositive is negation of unbounded is not bounded. Implies negation of convergent is not convergent. So not bounded implies not convergent. And the sequences which are not convergent, we are just going to name them divergent, nothing else. So statement A is every unbounded sequence is divergent. It is a true statement, but we have to look for false statement. So we have to look for false, and false statement is B, and B is our correct option. We are done. Let's move ahead. Oh, sorry. I took this space, but this doesn't matter. What I need to do, this is the graph of G prime. So the graph is the graph of derivative of the function, not the function itself, with domain 0, 7. So you can see starting point is 0 and ending point is 7. It is between 0 and 7. There's a graph and there is a derivative. Which of the following must be true? So I have again three statements. I have to look for which statement is going to be true and which statement is going to be false. Okay, for this one, I always draw the graph of G. Just roughly, what does the graph of G look like? So what am I doing? I'm just copying this thing. From 0, 1, 2, 3, 4, 5, 6, 7. Let me tell you one thing, that this is graph of G prime. When the graph is above x-axis, there's a positive slope. And when the graph is below x-axis, there is a negative slope. It means on above side, the function is increasing. and on below side, the function is decreasing. So let me tell you, from 0 to 2, the slope is positive. You can see the graph is above. So the function is increasing in that way. From 0 to 2, the function increases. So what I will do, I'll draw a function from 0 to 2. That's it. You can see I started from here. You can start from very general point. You have to just make an idea what is happening. From 0 to 2, my function increases. And from 2 to 5, my function decreases. From 2 to 5, my function decreases. So maybe, how can I go? Like from here, my function decreases when I reach 5. When I reach 5. So it should always decrease. It should never increase because the slope is negative. Then 5 to 7, you can see the graph of derivative is above, so function is increasing. So here function is, let's say, so the function increases till 7. When I hit 7, so you have roughly the graph of the function g. And on the left hand side, it's the graph. This is the graph of g prime of x, and this is roughly the graph of g of x, roughly. Now, look at the statements. G has a global maximum at x is equal to 0. At x is equal to 0, there is maximum? No. Look at the graph of g, not the derivative. And local minimum at x is equal to 4. So x is equal to 4, local minimum? No. So 1 is false. G has a, option 2, G has a local maximum at x is equal to, so you can see x is 2, this is local maximum. X is 2, this is local maximum. And local minimum at 5, this is 5, local minimum at 5. Statement 2 is true. G of 2 and G of 5 both are same. So G of 2 and G of 5. Since G of 2 is some sort of maximum, G of 5 is some sort of minimum, how they can be equal? No. So only statement 2 is true. So it's B. We are done. It's B. Okay, let's move ahead. This question is very good question. It says that in the XY plane, on this curve, what is the closest point to the origin? I will draw the graph of the curve. I know what is graph of square root of x. I can also draw what is the graph of square root of x plus 3. So I'm doing it over here. So y is equal to x plus 3. And obviously, I'm going to make the grid. When I substitute x is equal to 0, then y becomes square root of 3, which is some sort of 1.73. This is very simple. So at x is equal to 3, the value of y is, let's say, square root of 3. This is the value of y. And when y is equal to 0, what is going to be the value of x? So x is going to be -3. Just you solve, take a square, and we are done. So at x is equal to -3, y is 0. So -1, -2, -3. And you know very well the graph of a square root, like this, it can never go beyond this point. The reason is, if I put any x which is less than -3, this square root function becomes negative and I don't get a real valued function. So this is always the graph of the function. Let me just tell you that I have to find a point. Let's say the point is here, which is closest to the origin. This is our origin. Can you tell me what is going to be the value of x and value of y here? Let me tell you one thing. The value of x here is always negative because we are in second quadrant. You know that thing. And the value of y is positive. Value of x is negative. Value of y is positive. So you have options So one thing is that this can't be our option because the value of x is not negative. This can't be our option because the value of x is not negative. And minus 30 seemingly is this point, which is seemingly very much away, very much away. So this is not our answer. So our answer is either B or C. First thing you have to check is you have to substitute x is equal to negative 3/2 in this function to check that either the value of y is square root of 6/2 or not. But it is, you can check. And this is value of x, this is value of y. If any one of these values is going to be not matching the equation, you can exclude and you're at your answer without knowing, okay, how to find that. So sometimes these tricks work. But unfortunately, these 2 points satisfy the equation. So we cannot conclude which is going to be our answer. But I have to find the distance between this origin and this point. What is this point? Let me name this point to be x and y. But you know very well the value of y is square root of x plus 3 from the equation. And this is origin. Origin has always coordinate 0, 0. So the distance function is x2 minus x1 plus y2 minus y1. So the distance square would be, I'm just canceling a square root to make the things easy. So x2 minus x1, I can consider this point to be x1 and this point to be y1 and this point to be x2 and this point to be y2. So I'm going to just substitute the value, but I've cancelled square root already. So x minus 0 plus square root of x plus 3 minus 0 squared. This becomes x square plus x plus 3. I have to find what is going to be the minimum value of this because I have to minimize the distance. Let us name this thing f. You know very well for minimum, I need to differentiate this. So the derivative is 2x plus 1 and set this equal to 0. It implies x is equal to negative half. So here the value of x should be negative half and value of y should be just put in the function. You are done. So you can see out of these two options, our correct option is C, not D, not B. So the value of x is negative half as you saw. So the correct option is C. So look, without solving, we excluded 3 options. Now we are left with only 2 options. Out of those 2 options, we have to select either one of those. Very simple, a fair game. The last one for this video is a very simple question. We have f of g and we have to find out the second derivative of f of g, nothing else. Very simple question. You know calculus, you're done. So I will write f of g of x and I will find its derivative and I'll find its second derivative. So I'm keeping the outer derivative same. I'm differentiating for function once. You know very well I have to differentiate the outer function evaluated at g of x multiplied by the inner function g prime of x. This is a derivative. For the second derivative, since this is a product, I have to use product rule. So I have to differentiate this function again. So this becomes f double prime evaluated at g. An interior function is g prime and this g prime same. Plus, I have to evaluate, I have to write f prime of g of x same. It means this function same. The derivative of g prime becomes g double prime of x. We are done. So this is f prime of g multiplied by g prime squared because these are two g primes plus f prime of g multiplied by g double prime. So this is like you are not supposed to exclude any option. You are supposed to check that which one of these is correct option. So I think it is D. Yeah, it is D, because F double prime G prime squared plus F prime of G. Yeah, this is correct option. So we are done with 5 questions, and see you in the next video with other 5 questions. Till then, goodbye.